Hello students, this is Mr. Maat with another physics lesson. In this lesson we're going to focus on an experiment that I prepared for you. It's an experiment that has to do with Ohm's law. It tells you something about the relationship between the potential difference PD and the current. For next lesson there's of course some homework. Make sure you finish all the assignments in lesson 3.3.11. For this experiment, you need to go to a special website, Phet Colorado, and that creates interactive simulations. We're going to use those simulations a lot during physics, so make sure you get familiar with this website. I will place a link in Classroom and also in the video below, so you can follow me in the steps I'm going to take. So please click on the link and go to the website. Okay, let's start with the experiment and the first step. We need to build a circuit, use one lamp, a battery, a switch and a couple of wires. Close the switch and see what happens. And then there is a question formulated: what is the name of the moving particles? So let's start with the circuit. First of all, I'm going to take a battery. You always need a power source to start with. I also need a light bulb. So here it is. And I take a switch. It doesn't matter where you place a switch. I'm just going to place it over here. Move it a bit this way. And now I'm going to connect everything with wires. So I take a wire over here and it starts at the positive pole of the battery. I go to the switch. Then I take another wire. I go from the switch to the light bulb. You can do that just by connecting the wires. Also just immediately like this, but I just like doing it a bit in an orderly way. There we go. So here's my circuit. And my switch was already closed, so you immediately see what happens. Electrons start flowing and the light bulb lights up. Step number 2, you need to click on the battery. A screen at the bottom will appear. Turn the battery around by clicking on the symbol. I formulated 2 questions for you. What happens with the direction in which the electrons are moving? And what is the potential difference of the battery? So let's click on the battery. Here's the box that is going to appear, and you see there's a button over here. If I click on that, you see that the battery turns around. Well, at this moment, you see that this is the positive pole and this is the negative pole of the battery. Well, electrons are negatively charged, and that's why they flow anti-clockwise towards the positive pole. If I now turn around the battery like this, you see that the electrons are start moving clockwise towards the positive pole that is now situated on the left side of this battery. So it depends on how you actually connect this battery and which direction the electrons are moving. Well, you can also click on this battery, and if you click on the battery, you see there is a potential difference, the voltage given. And in this case, it's 9 volts. Step number 3, click on the battery and now increase the potential difference to 12 volts. Question 1, what happens with the speed of the electrons and what happens to the brightness of the lamp? So let me click again on the battery and you see over here the voltage again, the potential difference. Well, if I start increasing the potential difference, you immediately see that the electrons, they start flowing faster and faster. See that happening over here. So they start moving faster and faster, and that means more energy, because all those electrons, well, they are full of energy and they flow through the wire, through this battery, and that energy is converted into light. So because they are moving faster, more energy is actually converted in the light bulb into light energy, and of course also into heat energy. So let's put this one on 12 volt because that was the question, and you see 12 volt, it still gets brighter than with 9 volts. Step number 4, set the potential difference of the battery back to 9 volts. Take an ammeter from the box on the right side next to the voltmeter. Place the ammeter left from the lamp. What is the value of the current And if you triple the value of the potential difference, the battery, the value for the current will be. Please give answer to those questions. So let's click on the battery again. Here it is. And let's set this to 9 volt again. There we go. Now we take an amp meter, and you see that over here, and just move it in your drawing. I'm just going to connect it left from the lamp. So let's get rid of this wire. Let's connect the amp meter. We're going to do it like this. And you immediately see what the current is going to be. In this case, 0.90 amps. Now the question is this: if you triple the value of the potential difference, the value for the current will be, well, we're going to see what is going to happen. So this was set to 9 volt. Let's get it all the way to 27 volt. Here it is, 27 volts. There we go. You see that also the current gets 3 times bigger, because the current was 0.90 and it now is 2.70 amp. So there is a relationship between the potential difference and the amount of current flowing through your system. So if you double the potential difference, the current will be doubled. If you divide the potential difference by 1,000,000, the current is divided by 1,000,000. In step number 5, I want you to copy this table below. And what I want you to do is I want you to place the potential difference in the top row and the bottom row for the current in amps. So what you need to do is you need to start at 0 volt. So you turn the battery, the potential difference, to 0 volt, and you measure the current at that moment. Yeah, and you do that in steps of 0.5 up to 4 volt, and you every time you write down the current that is given in a circuit. So do this in your notebook and make sure you have a complete table at the end of step number 5. So if you did this correctly, you should get a table that looks a bit like this. So you see that the current actually increases by 0.05 amps every step. And it starts, of course, at 0. So a 0 potential difference gives you a 0 current, because there is, of course, no force pushing the electrons to the wire. So that's why this value should be 0. Well, the next step is that you need to create a graph of these values in your notebook. You need to plot on the vertical axis the potential difference in volt, and on the horizontal axis the current in amps. So you need to think about a good scale of how to set up a good graph for this. So make it as big as possible and make sure you're able to actually insert all those dots. And then afterwards, of course, you draw a trend line. Well, the questions are these: what kind of graph do you get? And the relationship between the potential difference and the current is known as. Please give answer to these questions. Well, the graph looks like this. You get all those dots, and if you draw a trend line, you see it's a straight line running to 0. You see the potential difference is on the vertical axis and the current is on the horizontal axis. Make sure you also give your graph a name. In my case, potential difference versus the current. Well, a straight line running to 0 always tells you that there is a certain relationship between the potential difference and the current, and that is known as the directly proportional. So that means if you double, for instance, the potential difference, the current will be doubled. But also if you triple the current, the potential difference will be tripled. So let's see how that works. So for instance, I take a current of 0.1. If I double that, I get 0.2. Yeah. The value for the potential difference is 1 over here, and I need to double that as well. I get 2, and you see that is exactly at the same dot. So those two quantities are directly proportional. Step number 7. In step number 7, you need to complete the table by calculating the resistance. Well, the relationship that you just saw in the graph in the previous step was the relationship between the potential difference and the currents. As long as you have a straight line running to 0 that tells you that the potential difference is directly proportional to the current, then you're talking about Ohm's law. And Ohm's law is actually formulated in this formula. And it works like this. The resistance measured in ohms equals the potential difference measured in volt divided by the current measured in amps. In that way, you're able to calculate the resistance of a circuit. So let's do that right now. Let's calculate the resistance of each value in the table below. Step number 8. Well, if you did your calculations correctly, you should see that the resistance has a constant value of 10 ohms. That's why you got that straight line running to 0. The relationship between the potential difference and the current is directly proportional. That means there should be a constant value. The constant value is the resistance. Well, this resistance is of course caused by the lamp. So please click on the lamp and check what the resistance is of this lamp. I have some questions for you. Was the value of the resistance given on the lamp the same as the one that you calculated? The answer should be yes. The second question, the resistance is a constant value up to 4 volt in this experiment. At a certain moment, the lamp gets very hot. The resistance won't be a constant value anymore. What happens with the shape of the graph? Well, the shape of the graph, if you go back to that graph over here, you see that the potential difference, if you increase the potential difference, the current will increase. But if the temperature gets very hot, that is not going to be the case anymore because you get a huge amount of resistance. So the potential difference will start going up, but the current is not going to be going up in the same way as before. It will go up very slightly. You need a lot of potential difference to actually get the same current. So the potential difference and the current are directly proportional as long as the resistor is constant. If the resistor changes, then it's not going to be constant anymore and Ohm's law is not valid anymore. Step number 9. Set the potential difference of the battery back to 9 volts. Click on the lamp. The value of the resistance of the lamp is set on 10 ohms. The ammeter shows a current of 0.90 amps. Step number 1. What you need to do, double the resistance of the lamp to 20 ohm. What happens to the brightness of the lamp? Question 2. What is the value of the current with the new resistance? And 3. By doubling the resistance, the current will become. What is the name of the relationship between the resistance and the current? And question 5. Which value stayed constant? So here's my battery. My battery is set on 9 volt and the lamp has a resistance of 10 ohms. And we also see that the current is 0.90 amps. The first thing that you should do is you need to double the resistance of the lamp to 20 ohms. So click on the lamp and put it on 20 ohms. You'll immediately see what's happening because the light is shining less bright. There is just more resistance. Less electrons will flow to this lamp, so less energy is brought to this lamp per second. So the brightness drops. Well, what is the value of the current with the new resistance? It's 0.45 amps. You started with 0.9 amps. So you see that the value is divided by 2. So if you increase the resistance, you make it twice as big, then the current will be twice as small. If you make the resistance 100 times as big, the current will be 100 times as small. So there is a relationship between the resistance and the current. We call that relationship inversely proportional. So that's the opposite of directly proportional. Where directly proportional, you double one value, the other one gets doubled. In this situation, if you double one value, the other one gets divided by 2. Which values stay the same? Well, you only have the current over here. You have the resistance over here. Well, let's click on the battery. What does the battery give me? The battery gives me a potential difference of 9 volt, and I didn't change this value. So the one that was constant in this case was the potential difference. So step number 10. you're now familiar with Ohm's law. Ohm's law was the resistance equals the potential difference divided by the current. What I want you to do, we're going to use this formula a lot doing physics, but I'm not going to ask you constantly what the resistance is by filling in the potential difference and the current. Sometimes I want to have a formula to calculate the current, and sometimes I want to have a formula to calculate the potential difference. So I want you to stop this movie and try to figure out what is the formula with these quantities for the current and what is the formula for the potential difference. Well, an easy way of doing this is just to take some values and just start mixing up those values. So I took a value of 3 ohms for the resistance, I took one of 6 ohms for the potential difference, and 2 amps for the current. Well, if I want to get a formula for the potential difference, that means I need to get a formula for U, and U represents 6. I have a 3 and a 2, so how to get to a 6? That means you need to multiply the 3 and the 2. So the formula to get the potential difference is resistance multiplied by the current. Well, the same can be done for a formula for the current. The current was a value of 2. I have a 6 and a 3. You all know 6 divided by 3 will be 2. So the formula for the current equals the potential difference divided by the resistance. Well, I hope this experiment was fun for you and was helpful for you to understand Ohm's law. Make sure you finish lesson number 3.3.11 from Classroom for next lesson. Thank you for watching and bye bye.